Hello, everyone. My name is Callie Clayton. I work in SPIBER's Global Client Relations team, working in our business development and product development department, selling and working with customers for product development for staple fiber, yarn, and fabrics, including denim. It's such a pleasure to join everyone today, and many thanks to Anna and the Trip and Blue team for having SPIBER for the first time. It really is a pleasure for us to join and get to connect with new companies, and we hope that you all reach out after the presentation and ask any questions after I share a bit more about SPIBER and our materials. So just to start, SPIBER is a Japanese biotechnology company. So what we're looking at on the screen here is an image of our headquarters, which is located in Yamagata, Japan. So off to the right is our facilities here. This is our office space, and then our single ton scale capacity production plant here in our studio. And off to the left is Keio University, which is the origin of SPIBER. So this is where the initial research was done, which resulted in the founding of SPIBER based off of this research. So just to speak a bit more about the core values of SPIBER, SPIBER is really based off of the concept of contributing to sustainable human well-being. We see this as our core value, and we do this by looking at sustainable development goals. So what are the social demands in terms of environment, food, health, social issues? We see this as being the core value in which SPIBER can contribute through our research in terms of science, technology, and the development of new materials through using proteins as a building block. So proteins we see as a renewable resource-based material, which can be used in different ways to create sustainable materials. So to speak more a bit about proteins, what you see here on the screen are images of different insects and animals in nature. So what is similar about all of these different insects and animals is that each of them are made up of proteins. Proteins are the building blocks of life, and the protein sequence is what results in different properties for your hair, your skin, your teeth. All aspects of life are made up of proteins. So proteins are made up of amino acids and amino acid sequences, which result in different properties, such as the hardness of the exterior of a crab's shell, or the water resistance of a wool fiber, for example, or the stretch and elasticity of the silk that a spider extrudes. So we have looked at these different properties as based off of the amino acid sequence, and seen this as a tool that we can use to design nature from the molecular level. So what you're looking at on the screen here are different amino acids, which are essentially the building blocks and tools that we have used to produce a new sustainable material. So what we have done is we have looked at the DNA sequences of different insects and animals in nature, as I showed in the past slide. So we have learned and said this DNA sequence results in this property, such as the water resistance or water hydrophobicity of a wool fiber is based off of this protein sequence. So we have taken that information and used it for our purposes of designing our own DNA sequence. So what we have done to produce what we call Brewed protein, as seen here on the screen, it is a trademarked name which we use to call our material that SPIBER is producing. What we have done is we have designed our own DNA sequence, which is then input into microbes through genetic engineering. Those microbes then feed off of sugar through fermentation and output protein. So it's output as a liquid and then purified and dried down into a powder. So this powder can be used to produce a variety of different applications, such as resins, filament and fibers, films, gels, foams, a number of different applications. Proteins are able to be used in many different forms. So to go into a little bit more detail for the process I just spoke through, we have the DNA, which is the inspiration. We produce our own DNA program through genetic engineering. The DNA is input into microbes through fermentation. Is input into microbes via genetic engineering. And then those microbes feed off of sugar through fermentation to produce brewed protein polymer. Brewed protein is then dried, purified and dried into powder, and then wet spun into a filament, and then cut into a staple fiber. So it's a staple fiber that can be cut at any variety of lengths. And because it is a extrusion-based wet spinning process, which is similar to that of regenerated cellulosic spinning, such as that of lyocell or rayon, other wet spinning processes, the filament in the fiber is smooth. So this is something that is specific to our process and is results in a smooth protein fiber. And the fineness of the fiber that we're spinning at this time is 1.5 denier, so it's quite fine, similar to that of a cashmere or baby cashmere fiber. So to show you a bit more of the process, what you're looking at here is an image from our labs in Japan. And what you see is fermentation conditions being tested. So seeing under what conditions, how much heat, water, nutrients, sugar the microbes need to efficiently produce protein and efficiently output protein. So this is our lab scale facility. What you see here is a scaled version of that process. So these are fermentation tanks. And this process is actually similar to the process of that of brewing beer, such as how yeast feed off of sugar through a fermentation process to produce beer. We have microbes feed off of sugar to produce protein. So it's similar, and that's why these fermentation tanks may look similar to that of beer brewing fermentation tanks. So once the polymer is produced through the fermentation process, purified, dried down, this is the wet spun filament, which you're looking at on this bobbin here. And then that filament is cut into staple fiber and spun into yarn, which you're looking at on these bobbins here. And then woven or knit into fabric or manipulated in other ways. So an aspect that you can see in this fabric is that there's slight luster or shine. So depending on how we cut the fiber and how we spin the yarn, we can achieve different effects with the brewed protein fiber. This here is a wool and brewed protein blended knit fabric. So we blend it with other protein fibers to achieve a similar effect that of wool or cashmere, depending on how the fiber is manipulated or spun. So this is a woolen spun technique for this knit fabric here. This is a fur material, which we currently have under development, where we've blended brewed protein with other fibers to produce a lofty fur-like material. This is an example of hair for wigs, which has been under development. As you can see, we're able to dye brewed protein fiber with a number of different colors, light, dark, and achieve a touch and look that is very similar to hair, as the brewed protein used here is 100% protein, which is similar to that of human hair. We can also use brewed protein for other applications, such as resins. And potentially in the future, these resins could be used for apparel applications as well. In R&D, we have a leather-based material what we see as a leather alternative. I'm using brewed protein as a base material and component for this. So in short, We have a variety of different applications. This is a summary showing the powder, which is spun into filament, cut into fiber, and then produced into a number of applications of spun yarn, leather, resins, etc. So for our purposes today, for denim, we're mainly focused on the staple fiber and spun yarn. So just to share a little bit more about the value of brewed protein fiber, we see the authenticity of this being a new material as being one of the key aspects. It has its own touch and look based off of it being the only material of its kind in the world. We have designed the molecule ourselves, so there's no other brewed protein fiber existing. Only SPIBER has a brewed protein fiber. Because of the way in which it's been produced, it has different aspects that are similar to wool in certain ways, cashmere, silk, cotton. There's a variety of different aspects which make it similar to different fibers and unique in its own way. Sustainability is another key aspect since there are no animals involved in the production process. We are able to decrease environmental impact in a number of ways. We're also working to move to 100% renewable energy for production facilities and production in general. So we are also targeting to decrease greenhouse gas emissions. There's also the ability to eliminate the dyeing process through a dope dyeing method for brewed protein fibers. So there is the potential for different production methods that could reduce other environmental aspects such as dyeing. So to speak a bit more about the products that we've produced with brewed protein and to speak specifically about our denim materials, I'm excited to share with you our first ever launched denim fabric that was launched with Goldman Zero for a top and pant set, as you can see here. The denim fabric that was used was a brewed protein fiber blended with cotton in the weft of this denim. It's a warp-facing denim with a 100% cotton warp and the blend in the weft. And the brewed protein faces the inside, so it's a warp-facing fabric, and so the brewed protein touches the skin on the interior of the fabric. One aspect that we have seen about brewed protein is that when we compare 100% cotton-based denim with a brewed protein blend of denim based off of fabric touch test results, we've seen a slight increase in smoothness and slip. So we believe there's the potential to produce a softer touch when brewed protein is put in the weft of a denim fabric. And because it touches the skin, being on the weft and it being a warp-facing fabric, we believe it could be a softer touch on the interior of the fabric for impact and touch with the skin. So both of these fabrics here are synthetic indigo dyed. However, it is possible for us to produce a natural indigo dyed fabric as well. All of the denim that we produce is based in Japan. It's produced all in Japan with different partners, and Nihon Munpu is one of our denim manufacturing partners. So what SPIBER does is produces the yarn, and then we work with denim manufacturers to produce this fabric. So another launch that I'm showing you here of our denim product with a brand is with Yoke. Yoke used the same fabric that Goldman Zero did, but you see here they did a wash to create a lighter look of the fabric and a different effect. Here's an up-close image of the fabrics as well. So just to mention, the brewed protein is 10% brewed protein blended with cotton in the weft and then 100% cotton in the warp. It is possible to produce higher brewed protein content on denim, and that's something we're working on and developing for the future to produce a higher percent of brewed protein in the weft and potentially in the warp in the future as well. Another product that we're excited to share with you is our Sumi Denim. This is a charcoal dyed cotton warp. It's organic cotton in the warp and organic cotton blended with brewed protein in the weft, with 10% brewed protein in the weft. And this is a classic Japanese style of denim dyeing. It is shuttle loom woven, so it is a selvage denim around 80 centimeters width. And the other denim that we offer is around 148 centimeter width as well. So this is one of the classic Japanese style denims that we produce, and it's also possible for us to produce other Japanese style dyed denims as well, if customers are interested. So this is exciting for us as we've just launched the Sumi denim a few months ago and are offering it for commercial sale as well as the other denim fabrics as well. We have cotton blended yarns and staple fiber as well, which we offer for purchase. So just to share a little bit about other products we've launched with different brands and customers. Here we have a cotton blended jersey fabric that was launched with Pangaea, a British brand launched last summer for a small collection. We've launched this hoodie in a chenille type yarn with the North Face and Junya Watanabe last fall. We've worked with Goldwyn Zero for other types of outerwear applications, blending brewed protein with nylon as well as wool for this outerwear type jacket. We've produced other cotton blends for t-shirts, jersey, wool blend working with Goldwyn, blending brewed protein in a woolen spun yarn for knitting. And we've worked with a Japanese couture designer for understanding new ways to work with brewed protein as material through his creative manipulation of brewed protein fabrics. In terms of the sustainability value of the material, we strive to be as transparent as possible with our impact, such as our life cycle assessment, which we have published this past year and has been third-party critically reviewed. We also have a sustainable sourcing policy and impact report that are both published on SPIBER's website for anyone to read. In terms of the impact of brewed protein, we have compared it to cashmere fiber as based off of the fiber fineness being similar to that of cashmere, around 1.5 denier. And when we have done that comparison, based off of our polymer production plant estimates, we see our impact as being less than cashmere fiber in greenhouse gas emissions, water use, purification, land use by this %. So we see the value of brewed protein in that there is a large potential for reduction of environmental impact. Brewed protein also is biodegradable in natural environments, in seawater, as well as in soil. You can see brewed protein here degrades at the same rate as cotton, while polyester has not degraded after 6 months. For the future, we're thinking of how we can become even more sustainable and what is the feedstock that is feeding the brewed protein, feeding the microbes which produce the brewed protein. So how we imagine being able to create a circular system for producing brewed protein is through a concept that we call biosphere circulation, where we take biomass or waste textiles that are natural fibers, collect them, then use enzymatic digestion to break them down into sugars and proteins, which then can feed brewed protein microbes, which then can produce the brewed protein from that waste to produce more yarns, fabrics, and thus creating a circular cycle of upcycling waste textiles to produce more brewed protein fiber. This is a program that we have in R&D currently, and we are building partnerships with key stakeholders that are interested in this concept and would like to collaborate to help us develop our guidelines for being able to produce a system of taking materials that would work within our enzymatic digestion process. We target 2026 to 2030 to be able to begin the implementation of this process. So in short, SPIBER sees a society of consumption as being a large aspect of the current textile industry. And what we aim to achieve is a society of circulation, a renewable resource-based material society that has a focus on producing materials sustainably and mindful of environmental impact through the inputs and end-of-life cycle of these materials. In terms of how we plan to achieve this and how we plan to achieve to have great impact in terms of sustainable development goals for society is by scaling our production of brewed protein, so to make it accessible for all customers to use in a variety of different applications and within the denim market. So we're producing a single-ton scale of brewed protein polymer in Japan currently. We're scaling production in Thailand to reach a maximum of hundreds of tons per year. In the future, we'll produce at a thousands-ton scale per year in the United States. So I will end our call, end this conversation and talk on an image of our Thai plant, which is our future production of hundreds ton scale of brewed protein polymer. It's been such a pleasure to share about brewed protein and SPIBER's vision with everyone here today. And please feel free to reach out with any questions or interests in our materials. We're offering staple fiber yarn and fabrics and are open to any discussions for development interests. Thank you very much, everyone.